Welcome to the AI Research Roundup. I'm Alex, and today we're looking at a paper from the Hugging Face trending list, published on July 20th, 2025, just 2 days ago. This paper introduces a new framework for training information-seeking agents that achieve state-of-the-art results on the GAIA benchmark, reaching a score of 60.1. The paper is titled WebShaper, Agentically Data Synthesizing via Information-Seeking Formalization, and the way it generates training data is a really clever shift from previous methods. It formalizes information-seeking tasks using set theory to build better training data, avoiding common issues like inconsistency. So let's dive right into the results. This first figure shows a performance comparison on the GAIA benchmark, and right at the top, we see the WebShaper 72B model, scoring an impressive 60.19. This score puts it ahead of other strong systems like Claude Sonnet and various Gemini models. The key to this success is how it's trained using a method the authors call knowledge projections. A knowledge projection is a way of formally defining a task, using set theory to describe relationships between pieces of information, which helps build much better training data. Building on that idea of knowledge projections, this figure really illustrates the core paradigm shift. It compares the old method with their new one for training what are called information-seeking agents. Basically, AI is designed to find and synthesize information to answer complex questions. The old way, on the left, was information-driven. You'd find data, organize it, and then try to create questions. But their new formalization-driven approach, on the right, flips that. It starts by defining the task structure first, and only then does it collect the necessary information. This proactive step is key. So here's what that formalization looks like in practice. This diagram breaks down a complex question about a football player using their set theory approach. Each purple shape is one of those knowledge projections, a set of items defined by a specific relationship. To find the answer, the system combines these sets. For example, it finds the intersection, which means the items common to both, the set of teams founded in 1966, and the set of East German teams. The structured method is exactly how they build complex, consistent training questions from the ground up. And this next figure shows exactly how they build up that complexity. They start with a simple seed question on the far left. Then, an automated process expands it. The diagram compares a few methods, like a random structure or a simple sequential chain. But their key innovation is the layer-wise structure on the right. This method systematically builds out the reasoning path, turning known facts or constants into new sub-questions called variables. This layer-wise approach is what prevents reasoning shortcuts and creates genuinely challenging problems for the agent to solve. Alright, so this table details the main results on the GAIA and WebWalker QA benchmarks. It compares different base models or backbones with various frameworks. And the takeaway is pretty clear. The WebShaper framework, highlighted in bold, consistently outperforms other open source methods. For example, using the QN 2.572B backbone, it hits that 60.1 score on GAIA. The results also show a big boost from using reinforcement learning, which is a training technique where the agent gets rewards for making correct choices, adding up to 13 points on GAIA. Now, to give you a feel for what this synthesized data actually looks like, this figure provides a great case study. At the top, you see an incredibly complex question in plain English, and below that, you see how their system represents this exact same question. On the left is the formalization, which breaks the question down into logical pieces. Each piece links a variable, which is an unknown to be solved, to a constant, which is a known fact. The graph on the right then visualizes this, showing the multi-step reasoning path required to find the final target answer. So, what this all comes down to is a fundamental shift in how we create training data for these agents. Instead of passively gathering information and then trying to form questions, this formalization-driven paradigm lets developers proactively design the reasoning structure first. By using those knowledge projections, which, remember, are sets of information defined by specific relationships, they can build genuinely complex and consistent problems. This method clearly pushes open source agents to new state-of-the-art performance. That's all the time we have for this edition of the AI Research Roundup. Thanks for tuning in.